My name is Christine Chambers, and I'm an engineering manager at EMCA. Our B excavator has been on the market for a couple of years, and we have initiated an update effort to be more competitive. Our business development team has collected feedback from customers, and the engineering team has derived 5 improvements based on this feedback. Let me walk you through the MODSIM approach taken at EMCA, in which modeling and simulation are integrated to efficiently and rapidly engineer these improvements on our B excavator. EMCA uses the 3DEXPERIENCE SolidWorks as a CAD system, and we connect to the 3DEXPERIENCE platform for our project management and simulations on the cloud. We rely heavily on the digital twin approach to develop our products and improve them. Besides me, our team is comprised of 3 engineers located in different offices worldwide and 1 supplier. Jung-Ho Min is our mechanical design engineer working from our Seoul office in Korea. He was tasked to tackle boom modifications to increase load capacity and the redesign of our rollover protection bars to meet new safety regulations. Dipali Rajni is our HVAC engineer based in our Bengaluru office in India. She is responsible for redesigning the HVAC system and validating the cooling efficiency and operator thermal comfort to address some customers' complaints. The design of the new operator seat was given to one of our suppliers in Mexico that also used 3DEXPERIENCE. Lorenzo Ramirez is a plastic part designer collaborating with us to redesign the operator seat. Our last teammate is Ilda Fiore, who is an electromagnetics engineer from our Turin office in Italy. She was asked to identify the optimal location for the placement of an antenna for a new intelligent operation system. This project was entirely managed through 3DEXPERIENCE. All stakeholders were connected to the 3DEXPERIENCE platform through a collaborative space with controlled data access. This allowed everyone to collaborate, communicate, and share results. As the project manager, I created a dashboard that included the requirements and KPIs for every element to know when the development targets will be met. The dashboard also shows the latest proposed geometries and the simulation results for each element in development. Such a dashboard improves communication inside the team and provides rapidly the status of the project. Let's look in more detail at the improvements we worked on. For the boom, we targeted an increase of load capacity. Jung-Ho was able to leverage a broad suite of element types to efficiently model the different parts and reduce the structural simulation turnaround time. For the durability study of the side link, we used test data to model the high and low cycle loading of the link. We leveraged the strain-based fatigue approach for high-fidelity results enabled by FE-Safe solver technology. The auto-partitioning for solid hex meshing reduced model preparation time significantly. The results were shared in our project dashboard, and the new thickness was identified within a few iterations. New regulations mandate the rollover cage be able to sustain a higher peak reaction force. Jung-Ho leveraged the shell meshing capabilities to discretize the rods efficiently, and used automatic line fasteners to make the assembly. The Abacus solver-based explicit analysis was used to prescribe a fixed displacement to the top of the cage, and the corresponding reaction forces were computed. The rod dimensions were modified in SolidWorks, and the simulation model was updated automatically. The results were compared to finalize the design changes. On very hot sunny days, the cabin took a long time to cool down with the AC turned on. Dipali evaluated the airflow distribution across the HVAC registers and the uniformity of the air velocity coming out of each register. The HVAC ducts were modified to minimize pressure drop, ensure uniform flow distributed to the cabin, and maximize flow uniformity at the exits. Dipali performed a parametric design study to assess the HVAC performance across various blower speeds. I was able to see the overall improvement in HVAC efficiency on the project dashboard. The results from the HVAC redesign were used as input to assess the cabin cooldown time during a hot sunny day. Starting from a 50°C cabin temperature, a transient conjugate heat transfer simulation was performed to evaluate time to reach the average temperature of 24°C surrounding the operator. The operator seat was designed by our supplier Ramco in Mexico. The back of the seat is made of a plastic cover that needs to resist physical shocks experienced while operating the excavator. Based on the injection molding simulations, Lorenzo at Ramco was able to see the quality of the plastic injection process, the cycle time, the warpage and shrinkage experienced by the plastic cover. Lorenzo added ribs inside the cover in SOLIDWORKS to increase its rigidity and meet the requirements. All the models and simulation results were shared with us in the collaborative space on the project dashboard. The intelligent operating system requires an antenna to locate the excavator operating on site. The intensity of the electromagnetic field in different directions is our main indicator here. To study this, Ilda used the electromagnetics engineer role on the 3DEXPERIENCE platform to simulate the intensity of the electromagnetic field for the selected antenna in any given direction and identify any potential problem. In summary, in this excavator upgrade project, we fully leveraged the 3DEXPERIENCE Works portfolio to meet all the requirements defined at the beginning of the project. We defined a collaborative space that allowed everyone, even the supplier, to work on controlled access data. We hence updated the B excavator's digital twin and tested all improvements without having to build any prototypes. The MODSIM approach enabled by the 3DEXPERIENCE cloud platform allowed us to tackle improvements in strength, durability, manufacturability, thermal comfort, and electromagnetic efficiency. It helped us meet our targets in a timely manner while reducing prototyping costs and ensuring enhanced product quality.